Okay, on to question number 4. So we're given a stack frame from the debugger, and we know that this has a user function in the stack frame and a main function in the stack frame. So we're referencing our sort of layout of what a stack frame looks like when we have a main function and a user function that we've called. So to start here, it says A, if EBP main was found to be BFFF F818, what is the value of the return address saved above main's stack frame? So we know that main's stack frame starts at 818, so it's actually pointing to like that byte, right? EBP main, and that is usually a garbage value. We don't know anything about it, but then the data for main would start here. So we know main functions variables are somewhere starting right in there. So that would be a main function variable there. And then we know that there's some user function arguments, a return address, and prior EBP. So how do we find the return address value if we only know what EBP main is? Well, we want to look for what prior EBP is, and then we know that the byte or the set of 4 bytes below that is the return address, right? And so let's just look through here and see, do we find something that looks like BFFFF818? Well, that's right here. That looks like that, right? Keep in mind that this is in little endian order, so BF, FF, F818 is what we're reading. Let's just scan through real quick and see if anything else looks close. Here's BF, FF, F810, but that's not quite the address we want. And so nothing else matches, so that must be our prior EBP. Is stored at that location. So that means the thing below that must be our return address. And keep in mind, again, this is in little endian order in memory, so the little part is the 10 here. And so we're going to just read this value, these 4 bytes from right to left, and write them down here. So 08048410. OX 08048410. That's our return address. And we know that, again, because we found prior EBP that's given to us in the question, and then we know that this is what the stack frame should look like, as we have prior EBP and then return address. So next up, what is the purpose of saving the prior EBP address on the stack? Well, when we call a function, we need to remember 2 things. We need to know where was our data when we were in main, and where was our code when we were in main. So this is remember where the data was, or stack was in main. Because we're adjusting our stack, we're making EBP go to where it is for user function, right? We have a new ESP and a new EBP. The hardware doesn't remember those values. It only has one EBP and one ESP. So we have to save our EBP main so that we can remember that. We overwrite it. ESP is related to them, so we don't actually save that value in memory, kind of optimize it a little bit. And then what's the purpose of saving the return address? Same basic concept, right? We want to remember where the code was in main, or where we were in the code in main, maybe is a better way to say it. But either way, we have to remember where the data was. That's why we save prior EBP. We have to remember where the code was. That's why we have the return address. So then on to part D, if BBP main was found to be BFFF F818, what is EBP user function? Again, we're going to actually use the same thing we used in step A. So we see that prior EBP is here. And if we look at our diagram, we see that EBP user function is pointing to the first byte of prior EBP. And this makes sense because, like, if we look at what EBP main is, it's the byte below anything that we care about in that function, right? So main's function variables are above that. For user function, prior EBP is effectively garbage there, right, in user function, because we don't know there are no variables that are referencing that. So the stuff above it is our user function variables that are not garbage. And so we know that address then is 7F4 is the starting address for this line. So this byte here is 7F4. This is 7F5, 7F6, 7F7, and then 7F8. So it's going to be OX, BFFF, F7, F8 is our address for EBP user function. And then finally, the user function declares one integer type variable and assigns it a value. What is the assigned variable's value in decimal for the user function? So again, we need to look at our memory here, and we know that prior EBP is the last thing, the only thing above that is user function variables. So that is what's stored there. So we have in little endian order 000007D8. So OX 000007D8. And I'm just writing that at the bottom there so I can copy it. That's our hex value for that variable. And so we would have something in our code like int var equals, and we would most likely write this in decimal, though it doesn't necessarily have to be that way, but I'm going to go ahead and guess that that's what was required on the exam. And so that would be int var equals 2008 is the value we have there. So that's it for that question.